Good morning, students. Welcome to your physics class. We will be continuing with the chapter motion. In this chapter, we have already learned about types of motion. There are three types of motion: translatory motion, circulatory motion, and oscillatory motion. The first, translatory motion, is the motion in which the object moves as a whole along a straight path. It has two subtypes, rectilinear or linear motion, and the second one is curvilinear motion. When the object moves as a whole along a straight path, it is called a rectilinear or linear motion, and when the object as a whole moves along a curved path, it is called a curvilinear motion. Falling off an apple from a tree, a car moving along a straight path, a runner running along a straight track, all these are the examples of a linear rectilinear motion. And a packet falling from a helicopter, a car moving along a curved path, a runner running along a curved track. These all are the examples of the curvilinear motion. Then the second type of motion we have discussed is circulatory motion. This is the type of the motion when the object moves along a circular path. It also has two types, revolutionary motion and rotatory motion. A revolutionary motion or a revolution is the type of motion in which the object moves around another object in a circular path. For example, the earth moves around the sun and the motion of the moon around the earth. These are the examples of the revolutionary motion. Rotatory motion is the type of motion in which the object moves along its own axis in a circular path. For example, the motion of the earth around its own axis, then the spinning of a top around its own axis. These two are the examples of the rotatory motion. Now next we will discuss the oscillatory motion. Oscillatory motion, let's read the definition first. If an object moves to and fro from its position of rest, then the object is said to be in oscillatory motion. Now first we have to understand what is to and fro motion. Now if you have seen this, the pendulum, the pendulum clock has the pendulum. It is moving to and fro. Then the girl which is swinging is again a motion which is called to and fro. So these are the examples of a to and fro motion. If you see if you see this type of motion, this is called oscillatory motion. Then there's an activity given on your book that suppose a pendulum is moving from point A to O, then to point O to point B. Then the point A and point B are called the two extremes. When the object moves from one extreme point to its mean position is the point O. When the object moves from point A, that is first extreme position, to point O, which is the mean position, and then from point O, so that is from mean position, to the second extreme position, that is point B, then the object is having an oscillatory motion. So there is another definition of oscillatory motion which says that the motion, it is the type of the motion when an object moves from mean position to one extreme position, then to other extreme position, and then back to the mean position. This type of motion is called oscillatory motion. Now vibratory motion, this is another type. This is a type of an oscillatory motion where some part of the object is having a to and fro motion, where rest of the parts are at rest position. If you have seen some musical instruments, it will be clear to you that all these musical instruments are having vibratory motion. For example, a guitar, a violin, in guitar and violin, the wires are moving. Wires are having to and fro motion, whereas the rest of the part of the guitar remains at rest. So we can say that all the musical instruments are having vibratory motion. Now, there's an activity to demonstrate oscillatory motion.